Section 3.3, page 43, expanding brackets and collecting like terms. Let's just start with some basic ones in question 1. Got 3 bracket x plus 4, I'll multiply out. 3 times x, 3x, 3 times 4, 12. Done. Now let's just do D. 3 lots of 2p plus 5. Well, 3 times 2p is 6p, and 3 times 5 is 15, and it's positive 15 because the plus right there. We'll do the last one. 11 brackets 7 plus 3m. Don't be scared of this one. 11 times 7 is 77, and 11 times 3 is 33. So I've got 33 m's plus the 77. That's it. Question 2 is more where it's at because we have rectangles. So instead of playing with brackets, we've got a rectangle, and this length is called 5a plus 1, and this length is called 3. To find the area of that, we just multiply 3 by 5a plus 1. So 3 by 5a plus 1. So 3 times 5a, 15a's, and 3 times 1 is 3. That's all there is to it. Let's just do D now. D, get another rectangle. Try and find the area inside there. I've got 1.5 times D is the length across the top and indeed the bottom, but anyway, and the width is going to be D minus 2. Essentially I've got to multiply these two sides together, so 1.5D multiplied by D minus 2. Here we go. 1.5D times D, well, we know D times D is D squared, so I've got 1.5D squared, and 1.5D times 2 is going to be, well, 2 1.5s is 3, isn't it? So I've got 3D, and it's minus 3D because the negative just there. I'll do the last one, and I'll draw it over here. We're probably going to crash into our little rock climbing chappie, not rock diver, sorry. So, sorry to him, you know. Don't really call a rock diver, does he? Right, 3 minus f, that's that length there. And at the bottom I've got 5.5 lots of f. Just multiply out to get the area. 5.5 f's multiplied by 3 minus f. 5.5 times 3, 15 plus 1.5, 16.5 f's. Then it says minus, so 5.5 f times an f. Well, f times f is f squared, so I've got 5.5 f squared. Very ugly, but very, very true. Okie dokie then. That's the last one. Question 3 is rated at grade C. I won't read it, it was a lot to read, but you've got to be able to take word problems and write a little piece of algebra that goes with it. So it spins a story about Dora and Jim, which I won't read, but it says write each of these number puzzles as an expression using n for the missing number. Now listen to me carefully. It says on 3b1, think of a number, subtract 8, and then multiply the answer by 5. Okay, think of a number, n, that's what they said, subtract 8, n minus 8, and multiply the answer by 5. Now if you were to do that, it'd be completely wrong, because you want to multiply the answer by 5, not just the 8 by 5. So what you've got to do is rub it out, and that was a deliberate mistake for a change. To multiply the answer by 5, we need to bracket it off, put a 5 in front of the bracket, as if we were going to multiply it out. That would give us in fact 5n minus 40, and if you left the times 5 at the end, then you would have got n minus 40, and that would have been completely wrong. Now here's the next one. Begin with 10. Then it says and subtract the number, so we 10 minus n, the number, multiply the answer by 3, so it's bracket, and put a nice big 3 in front of the bracket, and then add 3 times the number, then add 3 times the number. So that's quite complicated, and that's grade C rated, and that's it on that score. Question 4 is all grade C rated. Let's turn over the page and we'll do some of these. Find an expression for the shaded area of each shape. Well, I've got to draw each shape first, roughly, and then expand and simplify your answers. I've got this, and then it goes like that, and then like that, then like that, and it closes off just there. And I've been given a dotted line there across there just to give me some guidance as to how to do it. That is n plus m across there. That is 6, maybe centimetres, who knows, and that is n across there, that little bit, and that is 5 across the bottom there. So let's find the area of this shape. It's obviously two rectangles stuck together. If I do the top one, I've got 6 lots of n plus m. Now I've got to expand it and then simplify, when I'm going to do you in a minute. And this little bottom one is basically 5 times n, so I just call that 5n. Now I can't stick that onto this end yet until I've multiplied this out, so let me just do that. 6 times n, make it a little arrow, called 6n, and 6 times m is called 6m. Now let's put it all together. I'm going to call it total area. It's going to be 6n plus 6m for the top part, and plus 5n for the bottom part, and that's the whole area accounted for. What have I got in total? I've got 6n, 5n, that's 11n's, plus the 6m's, and that's done. That's easy. I think I'll do question D. I'll draw it here and try to avoid this irritating little geezer there. Right, I've got that. I've drawn it rather small. Let's hope it shows up on the vid okay. This big rectangle here is called 12 plus k lengthwise, and this length here is just called k. So that's k across there. And this little one has got a width of 12, and it's got a, it's really hard to see this, so I'm going to draw an arrow there. That little length there is called k minus 11. Got the picture? And the shaded area, let's get some red on it, is all this. So if you imagine, I've got a big rectangle that measures 12 plus k times k, and I've got a little baby one which is 12 multiplied by k minus 11. So now I've got to do that little bit of maths, alright? So the shaded area is basically, if you imagine like a picture frame with a picture taken out, that's the picture. I've taken it out and I've got a nice fat frame. So let's just do the big one first. I've got 12 plus k multiplied by a single k, that's that big side done, and I've got k times 12 is going to be, well, 12k, that's that little bit, and I've got k times k, well that's k squared, and that's the big rectangle done. Now the little baby one there goes 12, that's across there, multiplied by k minus 11. Bust it open, 12 times k, well that's 12k, and 12 times 11 I think is 132, but let me just check that. I think it is actually, so 12 times 11, 132, yes I'm right. So that's minus 132. Now, to find the shaded area, I've simply got to take away the big bit and then take away the little bit from it. So let's just write it underneath here. I've got 12k plus k squared. Then I've got to take away 12k minus 132. Now this is tricky, be careful. So far I've got 12k plus k squared. Now if I minus 12k, simply minus 12k. But if I minus 132, I'm essentially saying minus 1 times minus 132, which is plus 132. So now simplifying, I can see that my 12k's minus 12k's have gone bye-byes, and I'm left with k squared plus 132. Not too sure how visible that is, so let me just red box it. Alright, k squared plus 132. Unbelievable, isn't it? But that's what it is. Time for one more. Let's do C on the other page, because it takes a lot of space to do these little things, doesn't it? Just do that one. Right. Actually, I'll do the last one because it's more tricky. I've got this little L arrangement here, and I'm being given a dotted line to help me see my way through the problem. That part is 2a, that part is a, right the way across the bottom is 4a, and this height is 3a. Now look carefully. The area of this part is dead easy. That's just 2a times a. Now, if this is 3 across here, I still need to work out the length across the top there, or this part across the bottom. It's the same as it's a rectangle. Now, if it's 2a right across that part, and then the rest of it has also got to be 2a, because 4a take away that little bit, which is also 2a, gives me 2a's as a leftover. You see, 2a here plus 2a there makes the 4a across the bottom. So now I can work out this one as well. So let's have a look. Let's change flavour. Let's do that one, shall we? I've got 3a times 2a, and then we'll do this one. I've got 2a times a. Let's go back to yellow. Right, 3a times 2a, 6a squared. What about you? 2a times a is 2a squared. Total area, and you ought to write the word total area there, is going to be 6 plus 2, 8a squared. And I'm very happy with that one. Now question 5 reverts back to standard regular algebra. No shapes involved, it's just involving multiplying out brackets, which you've done before. Let's just try one of these. Let's work up here. Let's do the first one. I've got 2 lots of a plus 4, and then I've got to add 3 lots of a minus 1. Okay, just like before, 2 times a, 2a, 2 times 4, 8, but it's a plus 8. 3 times a is called 3a, and 3 times 1 is 3, but it's minus, it's minus 3. 2a, 3a becomes the 5a, and 8 take away 3, 5. So it's 5a plus 5. That's that one done. Let's jump to, let's take a look. Find missing numbers to make each pair of these things. Anyway, I've done a completely different question. I've done question 5 without even reading it. But anyway, what I've done is multiplied out and simplified. So that's how I'm treating that question there. I want to go on to question 7. It looks like a challenging one of these things where you have to scratch your head and work it out. This is what I'm given. I'm given a rectangle. So it's question 7 on page 45. I'm told that this has a length of 3y minus 6, and this has a length of 2y, and he's got a little brother next to him like that, and I'm told this side is y minus 2. Well, actually this side is, but they're equivalent anyway. I ain't got the space to do it there. And I'm told that this length is 6y. Here's the punchline. Show that the 2 rectangles have equal areas. So I've put a little equal there. I've got to prove it. Essentially, let's multiply this out. 2y multiplied by 3y minus 6, because that's how you do the area of a rectangle. 2y times 3y, 6y squared. And 2y times 6, 12y. But of course it's negative. He's sorted. Now let me sort him out as well. This time I've got to go 6y multiplied by y minus 2. Here we go. So we've got 6y times y, 6y squared, and 6 times 2 is going to be 12 y's, and it's negative. There we go. I've just proved that both of them have the same area. The answers are 6y minus 12y. So you are equal to, yes, a dirty very big equals, isn't it? And I think I'll stop there because that's enough.